Welcome, everybody. Welcome to our workshop on one small thing, STEM version. I think we're working on the one that we had last week, the humanities, and we'll probably be posting that. Look for that on our wiki. It was very helpful, and it wasn't just for humanities people. So today, I fully expect to learn something from people because you guys are good too. All right. We have 4 panelists today. I will go in order here. Patrick Vernon cannot be here today, so we have a video for him. So I will go ahead and get started with that right now.
Hello, everyone. Welcome to this panel presentation. I apologize for not being able to make it in person. I had agreed to the presentation before I realized that I was teaching a class at the same time. So you're watching something that's pre-recorded. If you have any questions, feel free to send me an email to rvernon@xula.edu. I wanted to talk today in the One Small Thing panel about something that's been referred to in the past as the no-it rule. I don't think of it so much as a rule, but I'll call it that for this presentation. So I wanted to explain, first of all, what it is, what's the rule, why we want to use it, and why students could benefit from it, why it might be important, and how we might implement this. So just a little bit of background. The only official write-up that I could find about the no-it rule was in an MAA article back in 2011 by an Emily Sprague. But I feel like a lot of professors probably used this rule before. I had read about this and I thought, oh yeah, I do the same thing in my class. I've talked with some other math professors. We all use it. And I think this is probably used a lot outside of math classes too. And I thought this would be a great example of a one small thing because it is a very small thing that's very easy to implement. It doesn't really take any sort of framework to do. I apologize if I'm over-explaining anything in here. I feel like a lot of this stuff is pretty intuitive, but I do want to give a few specific examples just from my own class as to why I might use this rule. So when I first started thinking about this rule, it reminded me sort of this notion that I read about in the past called E prime or English prime. Maybe you've heard of this before. It's a modification of English that removes all variations of the word to be. And part of the motivation for that was that to be or is or am, those can mean a whole lot of different things depending on the context. And sometimes that can lead to a lot of ambiguity and a lot of confusion. So the constructors of E prime were suggesting to just remove that word and replace to be with what it means in each case. So I'm sort of doing the same thing with the no-it rule, not so much as a hard rule, but just sort of a general, let's say, a guideline. So why do I want students not to use the word it? I want students to avoid, and myself to avoid using ambiguous wording. I want students to really make sure that they understand what they're talking about. It is a really simple placeholder, but if you're using this placeholder too much, then you might forget even what you're referring to, as we're going to see in some of the examples. I also want to encourage mathematical rigor, whether this is a high-level proofs class or just an elementary level high school algebra class. Students really need to know what they're talking about moving forward. I think knowing what you're referring to and really understanding the problem is always going to make that a lot easier to solve. So I just wanted to give a few examples next. First example comes from my Intro to Statistics class. This happens probably every time I teach it. So each section, each semester, I'll hear somebody say, when we get to something like the central limit theorem, somebody will say something like, it's normal because it's more than 30. And that's really concise, but there are a few problems with this. One, what is it? And two, the students are referring to two different its in this case. The first it is referring to the sampling distribution of the sample mean, or of the collection of all of the possible simple random samples taken from a population, a very large population. And then the second it is just the size of the sample. So what students probably mean to say in this case is that the distribution of X bar is normal because N is bigger than 30. And really it's more approximately normal. So we should probably throw that in there too. Just a few more examples. Another one from statistics that just happened to me a couple of days ago. And again, this happens pretty much every semester. Somebody will say they're independent if they're equal. They're talking here about events. And what we know is that events are independent. Usually I think of independent events as being kind of unrelated. So one of the events happening does not make the second event more likely or less likely to happen, and kind of keeps everything the same. So they know that the students know that there's some sort of equal sign that should be used in a check for independence. Here they're using they instead of it, but it's just the same problem, pronouns. But again, the first they is referring to a pair of events, and the second they is referring to two types of probabilities. And if students just keep in mind the word equal, then the student, when checking for independence, will probably end up comparing two things that they shouldn't be comparing. The most common mistake I see here is if I have two events, say A and B, the students might just say if those two events have the same likeliness, then those two events are independent, which is not true at all. So yeah, the correction might be a little bit more wordy, but it's important that students really understand. There's a cleaner way to write this, but what we really mean here is the two events, that's the first they, are independent. And then the second they is the probability of one of the events unconditionally compared to the probability of that same event conditionally on assuming that the other event occurs. Those two probabilities are equal. It's an easy thing to check with an equation, but if students just keep in their mind when they say something like this, they're equal, then those students usually end up making a lot of avoidable mistakes. Another example from calculus, this is one that I think every calculus professor has seen before, something like it's decreasing because it's negative. So just to give a little bit of context, if you haven't had calculus in a while, a function is decreasing if, as in looking at the graph, as we're moving to the right, I guess it's this way on my graph. If I'm moving to the right, I'm moving downward in general. And if a function is decreasing, we'll say that the slope of that function is negative. If we use it in both of these cases, not only are we suggesting that maybe those two its are the same thing, but it actually has led students, typically, more than half the time, to actually equate those two its to the point where students believe that any negative function is decreasing. But that's impossible. I mean, imagine an increasing line. That line is below the x-axis sometimes and above the x-axis other times. So sometimes that line is positive, sometimes that line is negative. It has nothing to do with increasing or decreasing. The height of a function in an absolute sense does not have anything to do with the slope. It's more the change in height that affects the slope. So this one I think is a very important example. We can say a function is decreasing because the derivative is negative. This is something that students really need to understand. And then finally, a higher level example, one in discrete mathematics. I might give something, don't get scared by this notation. All I'm saying here is that I'm looking at a collection of ordered pairs x, y. You could sketch the graph of this collection in a plane, and you could check to see if this graph defines y as a function of x. And we could call that collection some set f. And in a set theoretic definition of a function, this defines a function. And students will look at this and just say, it's a function. And this is the one case I gave where we're not talking about two different things that are being equated, but I still wanted to show an example where the it is important to quantify. Here students are saying it's a function. Well, what's a function? Are you saying that this equation here is a function? Because an equation is either true or false, not the equation that's telling us a function, at least not this big main equation. You could say maybe that f is a function as it's defined here, as f is defined here, f is a function, f is the set. But that leads us to some other questions, because maybe somebody might think this is the same as saying y is a function, which would be incorrect. Or you could say y is a function of x, and that would be correct. Or you could say maybe this equation over here on the right is a function, and that would be incorrect. You would say that this equation defines y as a function of x. So all of these cases where you might use the word is as a shortcut are going to, in a lot of cases, lead to some simple and avoidable mistakes. And in a class as high as discrete math, it's especially important that students understand what they're talking about when they're talking about anything. So leaving out the it, then we might ask some extra questions. What is f? What does it mean when we talk about f of x instead of f? I notice up here at the top, I'm just talking about f without an x. So f of x is maybe what we get out when we plug in a specific x value. What is y? Is y a particular value, or is it any possible real number, or does y have some restrictions too? And do we even need to use the letter f up in the original definition, or could we just talk about that set inside of the braces as the function? So it really sparks a little bit more discussion. So I think the last thing that I wanted to talk about is how do we enforce the no it rule? And I don't really like to use the word enforce here, and I don't really even like to use the word rule. I don't associate any sort of negative consequence with students using the word it in the classroom, but typically what I will do is at least once or maybe twice through the semester, I'll remind my class while I'm lecturing that I will try in every case to avoid using pronouns, especially in cases like the ones that we've seen already. And I encourage students to do the same. If in the classroom a student uses pronouns, like in the examples we saw before, I may rephrase the question or rephrase the statement without using the pronouns. Or if I feel like maybe prodding a little bit more could be useful, I'll ask the student just specifically, what do they mean by it? Or, could you be more specific here? I might even write the sentence as they said it originally up on the board and maybe make some adjustments based on their feedback and feedback from other students. For something like an in-class assignment, like a quiz or a test, if a student uses a word like it, then this most likely will lead to them not receiving any points for the problem, or at least not receiving full credit for the problem because the student is not really explaining the entire solution. That's really everything that I have. I guess the last thing that I would say is maybe why do students tend to give statements like the ones that I mentioned? Why would a student prefer to use a word like it? And I think the answer really stems, at least in math, from the fact that all of my corrections are pretty wordy. And it's a lot harder to fit some big wordy expression inside of your head and remember it, at least for a test, but hopefully for 20 years, 30 years down the line, than it is to actually really understand what you're remembering. It's a lot easier to just say it's increasing because it's positive. And then that's like a little soundbite that you can remember. I don't feel like that's truly understanding. And in a lot of cases, this is what leads to mistakes. So students are trying to compress these problems down into easy to remember statements, and they're making a lot of mistakes as a result. So we've got the motivation as to why students use the no it rule. We've got some examples, and we've got, I guess I would say, how you could discourage students from using the words like it or they or that. That's really everything that I wanted to talk about today. Again, apologies if I'm really explaining this a lot more than I need to be. I just wanted to give a few examples. So if you have any questions, feel free to send me an email or if you see me in the hall, ask me some questions. Have a good day.
I actually wanted to say that this is where we got the idea for this one small thing was from Patrick. He told me he was doing the it rule, and I thought, well, that's really cool. Let's figure out, what that is and share with each other. So, and the article it came from is called One Small Thing. So he was actually the inspiration. So even though he couldn't join, I really wanted his voice here, so that's why he made the video. But I think we might be tempting the technology gods to try to do that. So if you all don't mind, we will send the link. Sound good? And give me a thumbs up. That sounds good. All right.
All right. Looking forward to that.
So we'll move forward.
Yes. So moving forward, we have Joanna Hay, who has graciously said that she would go second. So I'm sure she wasn't ready for this quick movement, but
Yeah.
I'll do department. And you have a PowerPoint, so I will get that up now. I need to. Where is that? Where I?
Three dots. Three dots.
Oh yeah, three dots.
Yeah.
Go to. There we go.
Good.
All right, thank you.
Okay.
How do we operate this thing then? Okay, there we go, figured it out. All right, so hello, everybody. I'm Joanna from biology, and I'm going to tell you about what we've been doing with the genetics lab. And hopefully some of what we do for genetics can be used in other courses. So the genetics lab is a lab that's taken by all biology majors. I don't know how to switch to the next slide.
I got it. Think. You just go there. Just
Okay. All right. So it's a course that's taken by all biology majors. So before I talk about the small thing, I have to let you know that we had to do one really big thing, which was redesign the entire course. And so we spent the summer, and so two of us teach a course. It's myself and Dr. Cecily DeFries. We redesigned the course to build a new genetics course, and it was done the fall of, and I can't see what's on there now, I forget, what was it, 2019? 2021? Fall of 2021, so it's pretty new, right? So we taught fall of 2020, no, whichever. It's a year now. This is the third semester. So we're on the third semester of teaching the course. And so we made these modifications. And the course aims to give students a real research experience in the classroom. The course is an authentic research project, and the goal was to improve the learning outcomes of the students. We had to change the curriculum, and the students work on a single project for the semester. We had to make new PowerPoints. We had to create these weekly writing assignments, which is what I'm going to focus on today because that's the small thing for today's talk. And we had to set up new protocols and new lab exercises that utilize multiple techniques in molecular biology because it's a genetics course. We included a pre and post-course survey to gather information on the impacts of the changes. And we also wanted to assess the students' confidence in STEM. Again, the instructors are myself and Dr. DeFries. So you don't have to be a biologist. It's okay if you don't understand all of this, but understand that the course is usually, and we've made changes each semester, but it starts with making the strain that the students are going to work in. Our model organism is yeast, the same yeast that's used to bake your bread. And so we spend the first part of the semester building the strain that we're going to then perform experiments. And so this semester, we're testing DNA damage sensitivity and testing DNA mismatch repair, which is what the gene that they're studying is involved in. So the students work in groups. They are assigned an uncharacterized MSH6 mutant for the semester. Essentially, we identify mutations that are in humans that have Lynch syndrome, which is a cancer syndrome. And then they either make the mutation or we give them the mutation on a plasmid at the equivalent position in the yeast gene so they can do analysis. They do pre-lab exercises to kind of force them to look at the information before they come to lab. If you teach lab, we all know we hate when they show up and they don't know what they're doing at all. They perform experiments in the lab. They also discuss articles, primary research articles. The big or the small thing, which I still feel like it's a big thing. It's hard to call it a small thing because it's a big thing with a lot of work. Yes, so it's their writing. So it's writing, and it involves multiple submissions and a lot of feedback, which includes feedback from their peers. So there is also a peer review session, and they do an oral presentation at the end of the semester because we want to really reflect a real research experience. You don't really get tested on your research, but you have to write up your research and you have to present your research. So the writing assignments are based on a single project that they're working on for the entire semester. Each experiment is designed to learn more about their assigned allele. So each group is working on a different allele or a different version of the gene. Each week, they update their lab report, and we give them feedback throughout the semester. They develop this single document for the semester, and the document is written in the format of a primary research article. I'm not going to focus on the revisions because I kind of told you about those already. So, but if you look at the schedule of the exercises, they start out by, we introduce them to the project. And then this semester, they created a map to kind of locate where all the genes are on their plasmid based on the sequence we got back from the company that made the mutation, right? And it's okay if you don't understand that part. Just understand they start by doing something on the computer and we introduce them to the project. Their first writing assignment is going to be based, or is they've already done it. It's based on their first week where we introduce the project. They make their map of what's on the DNA, the piece of DNA they're going to be working with, and then they do a restriction digest and gel electrophoresis. Doesn't matter what it is. If you're not a scientist, understand that that's their first experiment that they do. And when they submit their first writing assignment, they provide us with a draft of their intro and the first method and the first two results that they have, because at the end of the RE digest and the gel electrophoresis, they have data. And so they submit this first assignment. We do give them guidelines to sort of help them what's supposed to be in your intro, what is the proper citation format, and little questions to help them address these. The second assignment is the peer review. So we're at this stage right now. So the Freese's class did theirs yesterday. She has 2 sections and they were super critical, which was great because we encourage them to, find what's wrong. You're helping your peer by actually pointing out what needs to be fixed. And they've already started getting feedback from us. So they know what we think is not supposed to be in their report and what's supposed to be done right. And they're also given a rubric. It was based on Sarah Weaver's rubric that she uses for chemistry. We modified that for our biology course and for the questions that we're asking. But notice that this document has gotten longer. So it's now included. So in the first one, we're up to, I don't know how to go back, so I can't. The first one did not include the yeast transformation. So as soon as they do yeast transformation, they now add that to their document. So each week, their document keeps growing with the new method and the new results. And they're writing this up and also putting in their new data, right? Oh,
Yeah.
That's how
logic,
it's backwards.
right?
Yeah. I don't know how to say it any other way.
Right, so here their document's much shorter. It stopped at RE digest, but now they get to peer review week. We've added the yeast transformation. Same thing happens by second assignment. We now have a longer document and we're giving them feedback. So each time they're submitting, we're giving them detailed feedback. We sit down and read through these documents and make the corrections before they get them back. And it's more of the same thing, right? So the document keeps growing as we add the experiments. By the time, and each time I'm showing you the little block with the fourth assignment, it means that DeFries and I collect it and then we review it and then we hand it back. By the time they get to the final lab report, the only thing we haven't seen is their abstract and their discussion. So they've gotten feedback on everything along the way and have been editing and polishing up their document. Most of their points do come from writing because, well, as much as it is a lab, it's also important to do the scientific writing. And they do get points in the form of quizzes and the pre-lab exercises, participation points, and then their final group presentation. How do they feel about it? Who wants to guess? They think it's too much writing. So that's how they feel about it at first. Like, oh God, we have to do so much writing, right? But by the end of the semester, they realize that they've basically written their lab report. They kind of realize that halfway through, like, oh, this is the final lab report. Oh, wow, right? Yeah. And they can study from this document because everything they're including is the stuff that matters for the quizzes and the exams that we're gonna give them. right? So if you know your report, you've been editing it, you carefully are reviewing it, then it makes it easier for testing. So by the end, we only have the abstract and discussion. They report that they've written for other courses, but the scientific writing is very different. What they're also very excited about is the results in the end, because every semester we analyze a new set of mutants. And so there is no looking at your friend's lab report from previous semester because it's different and the results are never the same. And we've also like modified experiments. So, you know, the lab report from first semester looks nothing like the lab report for this semester, which is actually good.
And can I also throw in there that this is exactly what Kat's been preaching about, authentic assignments to negate cheating in the online world, right?
Oh yeah,
Right?
it's hard to cheat.
Yeah, good.
And we've started using, what's it called, Turnitin? Yeah, so then that helps us with checking for, you know, plagiarism and stuff. And, you know, in their own words, this is what the students have to say. Each week, this course, we completed the experiment we which will be used in the end to help us create a lab report. I really didn't enjoy doing the little experiments, which still lead up to the overall goal. It's helped me build on the knowledge from the week before. First lab course I've taken that I actually felt like there was a point. It had a point. I've learned a lot, and it has changed my mind about lab work or research, which I considered not my thing at first. I actually had fun doing the experiments, writing my lab report and making connections between my work and real world applications, because this is about cancer, right? They're looking at an actual mutant that was identified in a human being. We complained about the writing, but it was really beneficial, especially for the lab report. It would have been much more difficult without it, right? So they eventually do appreciate doing the writing. So the writing was also built into class time. So when they have incubation, so because they're experiments, sometimes you have to incubate in a water bath for 45 minutes. That's time for them to write. So it's okay, break out your computers, write up the method we just did, and then we can hop around and check and see how they're doing. We do meet with our students during office hours. They are slowly evolving into writing workshops. So they come, and there are enough of them that we have to just move to the conference room and take it there. It does require a lot of effort from the instructors. So if you were to decide to try to do this, my advice would be to do it for a smaller course. Genetics is a pretty big group. We have up to 135 students per semester. So that's a lot of reading for Dr. DeFries and myself, and a lot of editing. And we do detailed go through and make comments and cross it out and move this around and give them instructions on how to improve the document. And that's it.
All right.
So if there are any
Thank you very
questions, I'll take them.
Well, we're gonna do that at the end.
Oh, at the end, okay.
All right, next up, I have not met you, so Yannick Gu, would you mind giving us your information about the teaching that you have?
Thank you for letting us do some tech. Okay, back to it.
Thank you, everyone. Thank you to the colleague before. I came a little bit late and I enjoyed your presentation. I think I will consider parts of it in my advanced courses because it's much smaller number of students. My name is Ulwade Yannick Gue. I am in the physics department, and I typically go by Yannick because it's unique and it's easier to say. So I thought I would title my presentation of 3 slides called Small Things. And I will verbate more so than going through the slides. The slides are just designed to captivate you a little bit because of the nice colors and the instruments. I don't know if it's a saxophone or whatever that is. But so there's this guy called Boltzmann in physics who studied statistical mechanics. And I found it depressing to have the cover page of a book starting with death. But in the gloom of our life, there is a small light that can shine. And I think that sometimes when we want to motivate students, we want to show them the depth of the material. We can be serious, we can be also playful at times. And to me, the first approach is to grab them by the neck, which is make them realize that it's something important. So I will go with the email now that I received. And the first one is enhancing students' learning. In the approach that I follow, I shock them on the first exam, on the first test. And not that I consider the first exam to weigh a lot. Most students come back from the break, they are a little bit playful, they try to find a groove, and I try to give them a tougher exam to bring them back. Now, I have to be careful because some students, when it's the lower level courses, for non-major students, they are scared and they try to drop. So I try to recognize that issue and I try to address it before they feel panic. But the first test is try to make it difficult. And most students don't do well. And the next step is the next exam. I try to lower the level a little bit to show them that they can learn. Because if they keep on failing, they give up on the potential of learning. And when they see that they do better on the next test, they realize, oh, I can do it, I can keep on learning. And it becomes easier and joyful for them. Now, in the lecture, I am a little bit of a comedian sometimes. I don't appear like this at first, but I will spare you the joke I provide in the lecture. That's already a joke I just did now.
Yeah, I laughed.
So, but I try to present the concept in a way that is relatable to the student. And in doing so, for the non-major classes, which I sometimes teach, I try to understand the major field of interest. If they are pre-med, pharmacy, bio, and so on and so forth, I try to relate the concept, but I make it in a more real-life scenario. One course that I taught, which is the general physics for non-major, one of the first concepts is related to mechanics, which deals with change in positions, velocity, and so on and so forth. Most of our students have cars. We can sometimes speed on the road. So when I want to present the concept of acceleration, I remind them that when you drive on the road, you press on the gas. Now, when you see the police officer car ahead of time, you slow down by pressing on the brake. So on one end, by pressing on the gas, your speed goes from slow to high, which is a positive acceleration. And when you press on the brake, your speed goes from high to low, which is a negative acceleration. So through these real life examples, they see the connections of the concept. Now, I like visuals because visuals also helps us relate. And I try to encourage the students to read the word. Like the colleague talked about writing, I tell them writing starts with reading. Because if you don't understand the words, each field has the language. And we will assume sometimes that you know the language because we've taught it to you. So you need to practice the language. And when I do the review, every time I go over the importance of understanding what this word means in the context of the question so that they can figure out the suitable equations to be applied. So the second point, which is increasing students' motivation. each person, each instructor has different abilities. We have students also who have different abilities. But one thing we strive as instructor to do, and what I try to do, is to try to connect emotionally with the student. Because I think in my few years, I have observed that students, when they can connect with you, they feel like they can ask you questions more. They can come to your office hour more. And I pay attention. I know my students, for the most part, by name. I try to associate a rhyme to the name, and I make sure not to call them by that rhyme because some may take offense to that. But what I try to do is, if I forget the name, I say, give me the first letter. And then I try to remember the name. I call them by the name. In the classroom, I try to make it interactive. So I will have open questions. If we deal with a concept that calls for them to use like the kinematics equation to find displacement, I show them that an equation, essentially, you want to understand the meaning of the equation. It has variables. Pretty much everything in the equation is a variable. But when you use it, it means you must only have one unknown, one thing that you do not know. So what I try to do is understand the meaning of each quantity in the equation so that when you read the problem, you can identify the equivalent in the problem and suitably apply the equation. So knowing the name of the student is good because it shows that you care. It's not a burden to try to know the name because we have so many things we have to do, but at least you will remember certain students who try to be participative in the lecture.
Just a quick reminder, we've got about 2
Yeah.
minutes.
The last point, which is boosting engagement. It goes along with motivation, because when the student is motivated, when you know the student by name, you engage the student in the lecture, in the lab, you are also able to boost the participation and the engagement. And one thing I try to do, I am not a big fan of extra credit. So one of my mentors from Xavier taught me that you need to be sometimes in the mind of the student. And what I do is I give them what I call fake extra credit. Now, there is a disclaimer to it, which is I tell them I solve a problem and I say, okay, I don't solve it completely. When I see that they are not engaged too much, I say, okay, this is where I stop. You can finish it. And if you finish it, this is going to be an extra credit, but I don't tell them how many points. When they hear extra credit, they are all happy. They will go work on it, and I just give 1 point, or I give 0.5 points. But they don't realize it until the end of the semester. They keep on thinking that they are getting more and more extra credit, but it is pushing them to work on the problem more and more. So thank you. And I will stop here. Thank you very much.
Thank you so much.
We'll have one more and then we'll have time for questions at the end.
Yeah. Our next guest is a wonderful friend of mine, Stacy DiMaggio from the chemistry department, and she's going to share her. And I've found these are not small things. These are, well, they're little tweaks, but they make huge impacts. So thank you, Stacy.
Thank you. I don't have any slides. My one small thing is to get places on time, which I apologize for the overturned truck that prevented that today for me. But so I think when Elizabeth sent the email, there was a few things to address, and one was engagement, and that's really what I've focused on. The things I've done in my class for engagement are not novel or groundbreaking, but I'll share with you those just to kind of lead up to the one small thing, which is in my class, there tends to be very significant barriers to the engagement, which are not unique to my class, but they are very prevalent and pervasive every year. So my one small thing is trying to eliminate the barriers so that they can take advantage of the unnovel but tried and true methods of engagement. So I do teach organic chemistry, no one's favorite class. It is predominantly sophomores. No one has ever taken it as a free elective. I've asked every year. This is my 20th year at Xavier. And the class size has been up to 110 students in that lecture. Thankfully, those years are over. We got them down to about 80 for a while. And then very recently, we've been able to get them closer to 60, which it seems luxurious now, but I know that is a very large class size. So, and then it's a class students tend to be intimidated by or worried about, or has a bad rap. I'd like to say it has an unfair reputation, but it does have a bad rap. So it's a large class of sophomores who are nervous and intimidated and have heard, bad things about the subject. So that's where I'm coming from. So the engagement methods have been, they're fairly pedestrian. Years ago, there's always getting people involved and linking it to real life examples, asking a lot of questions to the class. But as we all know, especially in a large class where a lot of students are nervous, there's a few students that will answer and some won't. And years ago when the clickers were the hot thing, I avoided that because I didn't want my students to have to purchase yet another thing. I mean, they're already a little strained. So I never did anything like that. But when we were kicked online through COVID, and then we elected to teach half of our organic online the following year, and I took that on. I started embedding poll questions it was easy in Zoom. I can no longer see their faces. Their eyebrows tell everything. So like everybody does that. If they don't understand, their eyebrows go down. When they get it, they come back up. And so since it was a bunch of little black boxes on the screen, I couldn't see their eyebrows. So I put these poll questions to say, like, are you getting it? Do we need to go over this more? But the nice thing, I could download them and keep a copy. I mean, it would just show a general, overall rating of their answers. But I could keep a copy, and I said, all right, I'm going to bribe you with a little extra credit. If you're answering, I don't care if they're right or wrong, but if you're answering the questions about when we're asking them in class, I can give you some participation points since I know you're out there with the pulse, And they liked it so much, I've continued that. I do it now through Brightspace, so they don't have to purchase anything. And it's a survey, it's anonymous when I show it on the screen, but I can keep their answers. But of course, and that helps the shy students, the ones that will never answer class, they can still participate, and I can also get what they're thinking as well. And then it's multiple choice. I know the major errors, but that's not a substitute for let's have a conversation, let's have a dialogue, let's try to get students engaged. I'm always asking questions. There are a lot of questions in the notes that are not necessarily poll questions. And so the barrier there is they don't want to answer because what if I'm wrong? What if I make a stupid answer? I don't know what's going on. This is already intimidating to me. And so my one small thing is to I don't want to say like I expect them to make mistakes, but more of making mistakes is part of the process that we all just need to accept. We're going to make these mistakes, make them now with me, low stakes, and then don't make them on your exam. And that's really, I guess, my small thing is to make sure everyone is okay with that. And so when the first few weeks, I'm trying to drag questions out of people and no one wants to answer. Take one for the team here. Come on, just answer it. And they'll answer it. And if they're wrong, I say, all right, 30% of the class owes you a cup of coffee because you just made a mistake that 30% of the class made. Let's talk about it. And then I try to build in a couple more examples immediately after that. And then they start to get it right. And we see, okay, it took you 3 examples to get it right, but it's mimicking the process of studying. And it also is meaningful. And that's what I love about what Joanna is doing. These writings, they might seem tedious, but they see such a clear link as to why this is part of the process, and I'm getting immediate help from it. And so even as the class goes on, and I think this is normal for any class, they start to get a little bit more comfortable and answer. And students will even, like, if I'm asking a question no one wants to answer, someone will say, all right, I'll take one for the team today. And so they're kind of getting into it, and it's okay. Maybe that's their little an expression of lack of confidence, but it's also, I hope it's an expression of, so what if I'm wrong, you know? And then when they start getting it, then they'll say something maybe that's wrong. And now students feel more comfortable. Oh, I did exactly that. I did exactly that mistake too. And so they're owning up to it. And I'm building those in. These are common mistakes on purpose, you know, in these problems, let's get them out now. And then encouraging, like, so what if you're wrong? Everyone likes to talk about critical thinking, but really critical thinking is just a series of memories that you're linking together. And so if we are building all these memories, oh, in this problem, I don't want to go this way, I want to go this way. In this problem, I have to think of this concept, not that concept. We're building that in, we're making the mistakes, it's all okay. And then, you know, they start to, as they're getting things right, they're like high-fiving each other. And I think, you know, you look at me like I'm a total dork when I make organic jokes, but you have just high-fived on molecular orbital theory. So, you know, what does that say, right? But it's the idea that this isn't scary. It's just a lot of mistakes. It's a lot of information. And once we start doing it, we stop making those mistakes, or we make fewer mistakes. And then I even turn it on myself. Certainly I make mistakes. You know, if it's a typo or something obvious, I don't really, you know, someone corrects it, okay, let's move on. But if someone finds a mistake that I realize, if someone went to their notes later and tried to study, it would cause a problem. You know, I can't deduct 2 points from me, so I give plus 2 points to that person. So it's just a highlight of, I make mistakes too. I've been doing this for 25 years and it's okay. So let's all make them together, and it's comfortable, and there's no judgment, and it's a barrier to engagement. So the engagement methods are not sexy or novel, but, and I think there's an engagement barrier to all classes, but a large class of up to 110 sophomores of a class that everyone hates and no one wants to take, those tend to be very prominent barriers. And that's obvious.
Thank you so much. All right, it is question time, and you can. Do we have questions from the chat?
No questions in the chat right now. We got a couple of comments about appreciated the building on the assignment.
Yeah.
Janet, somebody said that's just a really good idea. The scaffold assignment, right, to get into the final. So people in the chat, if you put in the chat and I'll ask a question,
or real people who are alive here and getting a free lunch. Yes.
I'll have to quick question. I think Yannick, this is probably more answered with you. From my own experience, one of the things that I have done in the past, not only currently, but stepping in this one first semester here and stepping in and trying to get things all set up. But I've used what's called the ADDIE model, which gives questionnaires to the students multiple times over the semester for them to basically self-evaluate their own profession or their own ability. And I think that what you brought up about the idea of changing your own rigor along the semester, starting harder, easing up, and then hardening up again towards the end. I tended to see in different courses that I've taught that there's always self-inflation of their ability at the beginning of the class. They always believe in themselves more than their actual abilities are. And I tend to try to keep my level pretty sturdy throughout my classes because they will learn to, from my experience, approach you in a certain way and understand that your level, you're not going to change. You become a constant. And they learn how to adapt to your own requirements and demands. And that their own ability and self-understanding of how they're doing in relation to how to teach tends to fluctuate in a sinusoidal wave. In response to that, so they start up high with high expectations of themselves and overinflated abilities. Then you start testing them. I always ask them about things like, how are you doing in your algebra, your calculus, your writing? Rank yourself from 1 to 5. How's your critical thinking? How are you about expressing yourself orally? Things of that sort. And these are all different things that I'll incorporate into my teaching. And then, within the second or fourth, fifth weeks of the semester, well, they started off at 4.5 to 5, and it goes up to about 3, right? And then it starts building up again as they're using those skills that I'm using in my classes and teaching. The question is, do you feel that you have an advantage to actually changing the skill of what you're doing, as opposed to having them basically work, and you yourself in general, no matter how nice you are, and laughable and joyful, you're always intimidating as a professor no matter what. And given that that's the situation, do you feel that you need to actually put that effort or shock them at the beginning, or would they get the shock also on the road?
The level of difficulty of the first exam is not designed for me to oscillate in my approach. I think it's pretty constant, but I use the first exam to see how they understand the foundation, because I understand that knowledge is built up in staircase fashion. And if the foundation is flimsy, as you teach more, it becomes difficult. So I use it as a way for me to say, okay, where are they? What do I need to fix so that I can bring them where I need them to be? And when I was taking the specific case of the first quizzes, the grade distribution was like a bell curve, where like 75% were lowest grade, and you have 5% who were doing good, and 5% were kind of in the middle. So that's why I use this approach. But I see the point you are presenting, and I think I am keeping that point in mind.
The way I was thinking about always is that they will generally get to those conclusions. It might be very different in physics than it is in my field, macrobiology, which is a lot about novel ideas and thinking about contrasting vision and views and critical thinking, really. But as I said, I find that just by asking the question to evaluate themselves, it makes them think. It also, first of all, engage in the skills you're asking them to do in class. Right? Say, how you need to remember that we will be doing algebra, we will be doing calculus in this class. How do you feel about it? As we do it, do you still believe that you're doing well, or you need to be working extra hard? So just by the point of asking them this question, are you using it appropriately? Are you using it? Something that doesn't affect their grades whatsoever, right? It's a survey. They're giving me their opinion of how we're doing. But they're gaining that idea of saying, I need to keep in mind that I need to work on my algebra. I need to work on my calculus. I need to work on my statistics, right? I need to understand these things better. And also ask questions if I feel all of a sudden like I'm not getting it. Or maybe I was doing something wrong. That gets them to come and talk to us as well, which I find to be effective. Because it's lower stakes, is the way I think about it, than actually something that affects their grade.
Do we have any other questions, Elizabeth, from the, no, we're just making great comments. Okay. All right. I think we got a couple of minutes. Any more questions? Yes.
I have a question. So you guys do the experiments in a group, but is the paper individual or is it a group project?
Yeah, the writing is their own. So the only thing they do is they work together in the lab, which is something we encourage everyone.
Yeah.
And we also encourage them to actually work together. So I'm like, I don't care how you do your pre-lab. Even if it means you talk to each other and tell the other person the answer, guess what? You're already talking about it, right? And the goal is to just think a little bit about it before you show up to class, so that when you come to class, you're not like, right? So that they can do together, and obviously they can do the bench work together. The data they have is shared, but their writing must be on their own. But now they're reading each other's stuff, right? And the peer review, so they're seeing what other people's writing looks like and compare. Like, oh, mine's not that good, or mine's pretty good, right? Yeah.
Great. Good. All right. Anything else? So, any other questions? These are some really I enjoy being in CAT because of the people, but also the stuff that I learned. So I appreciate you guys so much, and thank you for being here. And one of the great things I learned about CAT was we have this wiki that we put so much information on,
When I first was told this would be my position, I spent like a week on that thing going, oh my goodness, whoa. Oh, this is great. Why don't we just give out a new link every week and just start doing it because it's some good stuff. But as you can see, we continue to do good stuff. So thank you to our presenters. We thank you very much and we appreciate it.
If you don't mind, you can just do it in real quick, 3 questions. We really appreciate it for our assessment data, just like y'all assessment data. People online, thank you so much for being here. Appreciate you, and I put the link in the chat, and we will send everybody the video.